Hi, this is question 5 of the Leaving Cert Ordinary Level Paper 2 from 2021. So as always, if you want a copy of the notes I'm working off, just send me an email at shanetroy@gmail.com, and that link should be in the description below. If you like the video, just subscribe to get access to more playlists. So question 5 here is in statistics, and let's read it through. The heights of a given population are normally distributed. Okay, so that's important. A normal distribution has certain things we can infer about it, and they have an image here of a normal distribution. And one thing that down the center, that would be the mean, and these would be the standard deviation, which is basically the deviation from the mean. So how far is the data from the mean? And I don't have an image of it here, but if you had one standard deviation, would take up around like 34% either side of the data, which in total would be 68%. So 68% of all the data is inside one standard deviation. Once you go beyond that to two standard deviations, that number increases. Okay, so that's what a standard distribution is. Not all things fall within a standard deviation distribution, but when the things do, we can infer certain things about it. Okay, just clear off that. So again, if I was doing this here, I might try put in, if I remember that that's the mean and that maybe that's the standard deviation. Okay, I'm going to put just SD for standard deviation. That alone would get me marks by identifying that you realize that the middle is the mean. It says that 95% of the population fall within the height range. Okay, so that's two standard deviations of between 147.9, they've marked that, and 178.7, they've marked that up here. It says using the empirical rule, find the mean and the standard deviation of the distribution of heights in the population. Okay, so this shows that the heights of this population are fairly spread out. Now, just anecdotally, I lived in Japan for a year, and one thing that I observed, and I'm not necessarily sure this is based on data, is that people were generally around the same height. There was tall people, there were short people, but it just stood out. And you might see the standard deviation of the populations there might be much tighter. Okay, in this population here, the data is more spread out. Okay, so you can infer that there's a bigger range of heights. More people are tall, more people are short, and just as always, the average person. Okay. Now, if I get rid of that, so the empirical rule, I suppose the first thing before we even use the empirical rule, the mean of this is the halfway point between these two pieces of data. Okay. So if I was to add them, 147.9 plus the 178.7, now I'm going to get them, it's 16, 8 minus 9 is 16 again, 7, 8, and 4 is 12, I wanted 3. So to start off with two decimal places, there's one decimal place here. Now I'm going to get the average of that, so 226.6 divided by 2, and I can do the maths of it to be 163.2, sorry, 0.3. My bad, I'm trying to do maths in my head. I should use a calculator. Okay, so that's the mean, 163.3. Now, what the empirical rule says is that if you have the mean, okay, that's the Greek symbol mu, the upper lower limits of the second standard deviation is either plus 2 pi, 2 sigma, okay, that's similar for standard deviation, or it could be the mean minus 2 sigma. Okay. Now, I'm going to take the one here that it is plus 2 standard deviations. So if I take the 178.7 and I take away the 163.3, now I'll do that on the calculator, which I don't actually have open. So that's 178.7 minus the 163.3. That gives me an answer of, in decimal, 15.4. Okay, so 15.4 is basically 2 standard deviations. Okay, it's equal to 2 sigma. So half that is, I think, 7.7 is equal to sigma. Okay, so my mean was 163.3, and that's centimeters, and the standard deviation is 7.7 centimeters. Okay, so within one standard deviation is 7.7 bigger and smaller. So 64% of people, like we said at the beginning, are 7.7 centimeters bigger or smaller than the mean. And if you go to 2 standard deviations, it's the 15.4. And that's 95% of the population. 3 standard deviations, I think it's 97.5% of the population, which is practically everybody. Okay. Now, the empirical rule, this is a hard question. If your knowledge of statistics isn't good, you're probably going to struggle. But if you remember about the standard deviation and even got the mean, you're fairly likely to get 7 out of 10 marks, which is a pretty good return, considering. Now, that's the answer there done out in the notes. Hopefully that makes sense. Okay. Now, the next thing here, part B, 10 marks, there's 3 parts to it. They've given you a graph here of the height versus the arm span. Now, they have it here for the females, okay, half of the table or more, and the males, the rest of the table. And it's got the height versus the arm span. So they've already plotted the data for the females. You have to plot the data for the males. So height is on the x-axis, the arm span is on the y-axis. Which is say this first one here, 168 on the x, 169 on the y. So 168 on the x is about here, 169 on the y is probably up here. Okay. Now I just continue doing all that. I'm going to go to the answer because there's no point in me spending time doing that. It's literally just the grunt work of x, y, x, y. And the coordinate there for the first one is basically 168, 169, if you were doing it in x, y coordinates. You're just plotting the different points. And you end up with something that looks something like this. The one I just plotted was that one there. Okay. So again, you end up with the whole pile of them. And you see here, before we even look at the rest of the questions, that looks like it's a fairly linear trend. In statistics, you might be able to calculate using software like the line of best fit, and let's pretend it's that one. And that line describes it's a linear model. It's not perfectly linear because people aren't perfect. We only have 20 pieces of data, and we're mixing genders. So, like, you'd expect there to be variability. If you had 1 million, okay, you might get a closer correlation, okay, because you've better data based on the actual population. Then you'd have to actually do it to know for sure. Now, what it's asking in the second part there, part 2, you see the answer, but the table on the right shows 3 numbers. One of the numbers is the correlation coefficient of the data shown in the table. Tick the one we think best represents the correlation coefficient between height and arm span for this data set. Now, initially I went 0.2 when I did this myself. I was kind of going, they're pretty spread out, but 0.2 is close to no correlation. Correlation goes from -1 all the way far as +1. A little bit different than probability, which goes from 0 to 1. So negative correlation will be going down. Okay, going down. Perfect positive correlation is going up. And all the data, perfect positive correlation, will be lined up like that. Now this isn't lined up like that, but it's not far off it. So the 0.9 is the correct answer. 0.2 will be just more spread out. Okay, so again, I was just wrong when I initially looked at it. I imagine if they'd used 0.8 there, I would have been personally more likely to pick it because it is a bit spread out. So it just kind of, I was like in my head going, it's too spread out. I would have got the 2 marks for this part by putting 0.2. Negative 0.6 probably got no marks because it's definitely not negative. It's not going down. And it says, explain why this correlation coefficient tells us about the relationship between height and arm span. And simply put, there is a positive correlation between height and arm span. Now, positive would be this. There's a strong positive. Okay. If it was 1, it would be a perfectly positive linear relationship, which in the real world is rare. The ology doesn't work like that. Anyway, look, that's question 5. I think that's the end of it is. Okay, so if you want the set of notes I'm working off, just again, send me an email at shanetroy@gmail.com. If you like this video, just subscribe to get access to more playlists.